Hello everyone. In this session, I'll be explaining a very simple code which performs linear search of any given element in the given array. Okay, what do you mean by linear search? First of all, we find if that particular number exists in the array, and then if it does exist, we find its position, that is the index value. This particular array has 5 elements. So index starts from 0, and if that element doesn't exist here, then we store a value -1 in the register R4. So now let's see what other things are happening here. This is nothing but an assembler directive area which defines a section of memory, and that memory section is named as lane position. Here code indicates the section of memory defined here stores instructions, and it is read only because we don't want any changes to be happening to the code during runtime. And entry here indicates where exactly execution starts. That is the very first label after the assembler directive entry. R0 is loaded with the address of this particular array using this particular instruction, and R1 is 1, that's the number we want to search. R2 is 5, which is nothing but the number of elements that exist here. R4 is 0, which indicates the initial index possible. Okay, and now in this particular loop, we take the first value, store it in register R3, that is nothing but the element 3, and we increment the address of R0 by 4, so that R0 will be pointing at the next location which is required for the next iteration. Then we compare R3 and R1. R1 is 1, R3 will be the element we have loaded using this particular instruction. We compare the element here, that is nothing but the first element, and the content of R1. If there is a match, that is if they are equal, comparison always performs subtraction, so the result will be 0, causing this branch to occur to an infinite loop. Okay, because already R4 will have the index 0, which is the index of the first element. If in case that is not true, addition happens, that is nothing but R4 is incremented by 1 to represent the index of the next value, and R2 is subtracted by 1 to indicate one iteration is complete, and if in case the subtraction resulted in 0, in that particular case this loop will be broken and we move here. But if R2 is still not 0, we are branching back to the loop. Okay, so this continues until either we have found a match, that is one of the elements here actually is equal to the number we are searching, else we have finished checking all the elements, so this particular condition becomes false, that is branch if not equal to, and we jump here to load a value -1 to register R4 to indicate the desired result is not found. So now since we know what's happening here, let's see if it works properly or not. We have checked there is no error here, so we'll go ahead with debugging. Okay, the very first instruction loads the address of array into register R0, which is nothing but 30, and you can see all the elements here. R1, R2, R4 are initialized. The very first value will be loaded into register R3. It is compared with R1, okay, because of which CPSR is updated. Now here Z is not equal to 1, because of which this branch is ignored, and addition, that is increment of R4 happens. R4 is somewhere here. Let's see that happening. Yes. Now we are subtracting R2 because one element is already checked, and we are branching back to the loop. Second element that we are considering is 7. This is also not equal, so just R4 gets incremented and R2 gets decremented, and the branch continues. The third element, that is nothing but the element at index 2 is nothing but 1, which is our desired value. So comparison results in 0. 1 minus 1 is 0, because of which Z is 1, and hence branch occurs to stop. Okay, and this is an infinite loop. Okay, so if you check the content of R4, index is actually 2. Is that answer correct? Yes, the value 1 that we are searching for is actually found at index 2, 0, 1, 2. Okay, so now if I change this code, or I try to search a number which actually doesn't exist in the array, then what will happen? We should get a value -1. Let's see if that happens. Okay, so looping happens. If you see here, it jumped to this particular instruction where R4 is loaded as -1, which is hex value, all Fs, and finally it reaches our infinite loop. Okay, the reason R4 is loaded with -1 is because that particular number 16, that is decimal 16, doesn't exist in this particular array.